All right, everybody, welcome back. Our next item of business is item D, and that is a report acceptance, Port Valdez weather buoy data analysis, and that will be with Roy Robinson and Ron Campbell.
Good morning, everyone. This project was to look at the Port Valdez weather buoys. They've been out in operation about 2 years now. We contracted with Dr. Rob Campbell to do an analysis of the data that they've been collecting through the end of last year. Rob and Alan Sorum have been the ones that have installed and maintained the buoys over that time. And it just made sense to start looking at the information these buoys are gathering and try to determine if there's any trends. We're looking at this project of being a series of projects through the next 5 years, and hopefully we'll be able to do this each year through those 5 years and determine if there's any long range weather trends or current trends in Port Valdez. With that, I'll turn it over to Rob.
Thanks, Roy. I imagine everybody here is pretty familiar with the history of the project. This is where the buoys are at. We got the first one over by the VMT off Jackson Point, basically between berth 1 and 2. That was in May 2019, and then in September 2019, we got a second buoy out by the Duck Flats, not too far from the container terminal. And so I'm here just to talk about some of the main results from having a look at the data we've collected so far. There's quite a lot of it already, and the patterns that fell out. Let's see here. Just to start off, I had a primer that I put in the report. Really, all you need to know is that today we're going to be talking about a couple different kinds of data. There's scalar data, which is just basically a number like temperature or air pressure or solar radiation, like the figure on the left. But obviously, when we're talking about wind or wave or current data, that has a direction as well as a magnitude. So that's vector data. So we have a couple of things that we're trying to show when looking at that kind of data. And yeah, this panel on the top right here is just kind of showing a vector is like, you can think of it as an arrow. The direction of the arrow is the direction of whatever you're interested in, and the size of the arrow, the length of it, is proportional to, say, the wind speed. And you can break that down into components, a north, south, and an east-west component. And I do that in a couple places. It just allows you to kind of simplify what you're looking at. And then to summarize this, I did it in a couple of ways. I did it with roses, which is this panel B here, and it's what we use on the website of the buoys as well. And so that breaks things down into bars that are the direction that the wind was traveling from, and then uses color to code the magnitude, the speed, the velocity. And another way to do that is this C-plot. This is called a quiver plot, and you basically just directly display the vectors over time. And I did that throughout the report. This one here, I included the arrowheads just to illustrate that idea, but in the report, I haven't done that because there's so much data that the arrowheads make it a little busy. And I should also mention meteorologists, when talking about wind, talk about where the wind came from, where everybody else is basically talking about where things are going, currents or things like that. And this, of course, annoys oceanographers and mathematicians because it's kind of opposite of what the vector is showing. But I adhered to that format for winds, except when using these vectors, because vectors are literally the arrow showing where things are going. So with that in mind, let's dive in. These are the time series of the scalar quantities from the two buoys at the VMT on the left, Duck Flats on the right. I've plotted air temperature, sea surface temperature about 1 meter below the surface, the relative humidity, barometric pressure, and solar radiation. For people like me who like to drink from the fire hose, I showed basically all the data. Every black point is an observation. And then those red bars are the monthly averages. And it's pretty much what you'd expect to see from a subarctic situation like we're in. Obviously, warm in the summer and then cool in the winter. The VMT and the duck flats are subtly different. If I draw a line across here, you can see the air temperatures are more or less the same, which is pretty much what you'd expect. They're not that far apart. But the water temperature at the duck flats is slightly cooler than at the VMT. And then that's probably the river output at the head of Port Valdez. There's a lot of ice above those rivers. So that's cooler water entering the ocean and giving it a slightly lower temperature. Relative humidity is all over the place, like it tends to be in a temperate rainforest. And barometric pressure, not a ton going on there. We see the low pressure predominating in the winter and maybe a little bit more high pressure in the summer. And then the solar radiation follows the temperature basically as you'd expect. Moving on to winds, this is the wind time series at the VMT buoy. It's the same data just shown with the roses on the left and the quiver plot on the right. Because the winds and really waves, current, everything in the port is mostly in an east-west direction, I had to stack the time on the y-axis, so the arrows are visible. And you can see here the winds in the winter are basically being driven by the big low pressure systems that we get and are easterly. And then in summer, it shifts to more westerlies. Oh, right, and I should also point out one thing that you might notice in all of these wind roses is there's always or often this one weird little northward looking point, and that's zeros. If the wind is so calm that the anemometer isn't turning at all, it means wind is zero, or sometimes in the winter it will ice up. And because it's a vector quantity, when there's no velocity, the direction is meaningless. So those northward points just give an indication of when it iced up or how often it iced up in the winter, or when it was really truly calm during the summer. And going back to those westerlies in the summer, those are basically driven by sea breezes. That's driven by atmospheric convection on sunny days. Basically, the sun warms up the land faster than the ocean, which makes air rise, which tends to draw air in from the ocean, creating a sea breeze. So I just took a little bit of the time series from the VMT buoy in May and June. I think that was 2019. And I've just taken that east-west component of the wind and then scaled it by, colored it by where it was coming from. And so you can see sort of in the middle of the night, there's obviously no sun. There's a little bit of a return flow from the east, but then during the day, generally around 10 o'clock to noon, the winds will pick up and start picking up to the west, and they're stronger from the west. So in the average, that gives us sort of an average west wind. These are the winds at the duck flats, and really they show pretty much the same pattern as at the VMT, like you'd expect. They're slightly higher at the VMT, and that's probably because that buoy is a little closer to the mountains and things can get squeezed against the topography. But same basic idea. Sea breezes in the summer and to the west in the winter. And this is just a time series of all of the gust speeds recorded at the two buoys. We had a little trouble with our recorded gusts initially. It turns out that the program for the data logger on the weather buoy that we bought from RPS had one setting set wrong. And so we were getting wind gusts of like 150 knots, which was obviously quite wrong. We've fixed that now, and I filtered out those bogus values for this report. But basically you can see the the record so far is just under 50 knot gust that we had last November. They're upwards of 20 knots max in the summer, and obviously more during the big. Moving on to the waves, the wave record is really best at the VMT. One of the wave sensors was wrecked by a power surge, so we prioritized waves at the VMT. Same plot as the wind, and as you'd expect, it lines up pretty much with the wind because the wind is driving the waves. Winter storms are making big waves in the winter, and then we have the sea breezes making smaller ones in the summer. This is sort of the equivalent to that gust plot, but looking at the wave heights. And our record was just under 7 feet, which is fairly impressive considering how little fetch there is in the port, really. But generally, we're seeing max waves in the 2 to 3 foot range. Now, this is the time series, all of the observations of currents made at both of the buoys. They have an acoustic current meter that's at about 1 meter, and it's side looking, so it's measuring quite close to surface currents. I can see they're generally higher at the VMT than the Duck Flats, and that's probably just because of the shape of Port Valdez. I kind of think of the port as a big bathtub, and I used to get in a lot of trouble when I was a kid in the bathtub. I'd scooch back and forth and get a good wave going, and it would slosh out on either end and have my mom come and yell at me. And the port kind of does the same thing. And so at the VMT, which is kind of in the middle of the bathtub, the water goes back and forth more, whereas at the Duck Flats, which is up at the head, the water doesn't have anywhere to go, so it tends to go up and down as it sloshes back and forth. So we see lower currents there. And looking at it in an aggregate like this, you really miss a lot of the detail, and there really is a tidal component. These are just a couple of the plots that we produce on the buoy web pages every 15 minutes. I just grabbed a random section. And at the VMT on the left here, this third panel down, the black line is the tide measured at the Valdez Harbor tide gauge. And the red dots are the current direction, and the blue line is the current speed. And you can see in the direction that the tides are generally flipping back and forth as the tides flip back and forth as well. Not always. This actually, you can see there's a little period here after a bit of a windstorm where the currents actually didn't switch with the tides, which made my life a little more complicated. I'll get to that in a minute. And then over here at the Duck Flats, it's basically the same plot. You can see it's a lot less coherent with the tides, again, because there's just lower currents at that location. But there was some desire to try and look at overall circulation from those current observations. And the way one generally does this is you just fit a tide model to your currents, and then you can kind of subtract out the effect of the tides and look at what remains. And when I tried that, it really did not work very well at all. And the results of that is the plot on the left. The red line is where you would like to see the points fall, and then the black dots are where things actually did fall, comparing with the model predictions to what we actually observed. So it's basically useless. So I cast around for a bunch of different methods and finally settled on this Gargett and Savage method, which you basically try to detect the high and the low tides and then fit a line through there. And so this panel on the right here just illustrates how you do that. We have the tides going up and down, and then kind of fit in between the high and low tide to get this sort of longer term average. And I tried that with our record, and it worked the best of all the methods I used, but it really didn't work super great. A lot of the time it just couldn't detect a tidal signal in the currents, and that's probably because the wind is overriding that tidal signal some of the time, like I showed in that previous figure. Really, all that fell out was in 2020. You can see the residual circulation to the east that you'd kind of expect to see just from the counterclockwise circulation in the port, but really most of the rest of the time it didn't really detect any residual currents. I think that probably would need to be a project unto itself to truly pull that out. I did compare the timing of the currents with the tides at the Valdez tide station, just to give an idea of how things are different between the buoy locations and what's happening with the tides. And I did that with a covariance. It's sort of like a correlation. You're just looking at if one quantity is changing, is the other quantity changing the same? Is it changing in the same direction? And then you look at it at different lags. So if I look at the Valdez tide station, and I look at the currents at the VMT buoy an hour later and see how they line up. And then you just basically look for a peak. And what we're seeing here is that the currents at the VMT and the Duck Flats are basically lagging the tide by something like 45 minutes. And that's, again, probably just because the water is sloshing around and it takes it a little bit of time to change direction. Right, and we have, well, at this point, a couple years of data, a little more. But I wanted to try and put what we have into a larger climatic context. And 2 years of data doesn't really tell you that much. And so to do that, what we do is we work with anomalies. And that's just a way of putting your observations into a longer term context. And so in this figure here, I just took, it's about 20 years of data from the Valdez tide station of water temperatures. And I just plotted every single observation by the time, the day of the year that it was observed. And so we get this big cloud of points, but you can see there's a clear seasonal cycle. And so what you do is you can fit an average to that over time. This black line here is just the weekly average. And then you can subtract your observations from that average. And then so each observation will then either be above average or below average, or every once in a while right on the average. So it tells you if things were, say, warmer than average or cooler than average, which is a nice way to look at things over longer timescales. And so I cast around, and I wasn't able to find a lot of actual data for Valdez, but I did find a Berkeley database that had some average temperatures and temperature anomalies for Valdez at various stations, either around the town or at the airport, going back to 1908. And that ended, I think, I forget the exact date. It stopped in the 2010s. So I basically took the temperature observations at the Valdez tide station and used those to backfill what I had missing from the Berkeley record and put together an anomaly time series. And so this figure here is that entire anomaly time series from 1908 to 2020. And you can see the warming pattern pretty clearly that we see worldwide, really. It's gone from pretty cold winters and the occasional warm summer to almost warm everything. Over the entire record, that's about a 5-degree warming in Valdez, or about a half of a degree per decade, which is what we see elsewhere in the Prince William Sound region. So I can take those temperature averages and then use those to look at the buoy observations to see what those anomalies look like. And that's what I have here. This is over just the buoy record monthly average temperatures at the VMT and the Duck Flats. Clearly warmer than average at the VMT. 2019 was actually classed a marine heat wave in the North Gulf and Prince William Sound. We were seeing excessive heat basically everywhere, and we see that in Valdez too. Trending towards cooler into 2020, but then it actually flipped warm again in spring of 2020. Trending again towards cooler. And right now, in this part of the Gulf of Alaska, we're close to the average to the climatology. You can see there's a bit of an offset between the VMT and the Duck Flats, and like I'd mentioned, the Duck Flats tends to be a little bit cooler than the VMT, and that's what's causing that. But you can see the trends are pretty similar, which is what you'd expect to see. That's kind of a weakness of using like a regional average, long-term average to look at a point like the weather buoys. But until the weather buoys have been out there for a good long time, we just won't have a long-term average of our own to compare to. And I think that's all I have for you. Yeah, so I'd be happy to answer any questions anyone might have.
Thank you, Rob.
This is Pat and Seward. I have a question. So the temperature deviations, are they like over how much time? I mean, I just got back on here, so I'm a little behind the curve, but is that like I saw that it was like a year thing. Do we see a trend going long term?
In temperature?
Yes.
Yes, definitely. It's been warming over the entire time period that we have data for.
Right.
And around the late 70s, early 80s, things really shifted towards generally warmer than average.
Right. And I mean, this is not a fair question, but I'm going to ask it anyways. Do you have any opinion on why that might be?
Yeah, that's global warming.
Yeah.
We see it everywhere in long time series these days.
All right, I got you. Thank you.
Robert Beadle.
Thank you, Robert. Rob, do you see any effects on the buoy there at by the terminal from tanker and tug activity? I mean, that's pretty powerful. I'm just curious if it showed up.
I haven't looked. I wouldn't think so. When I'm there servicing the buoy, there's often tankers and tugs coming and going. They sometimes make me wait. And they seem to really just be using berths 3 and 4. So they're fairly far from the buoy.
Okay, yeah, it just seems such big equipment that it might have a, something. But okay, thanks.
Thanks, Robert. Jim Herbert.
I'd just like to have the board realize that Rob has done a lot of work on this. He's not only been the mariner out there getting his hands dirty with Alan servicing these buoys, putting in those fancy batteries that the board authorized a while back, putting bottom paint on the buoys, all of that kind of grunt work, but he's also an accomplished statistician. There are hundreds of thousands, if not millions of points of data that he's crunched in order to make all those diagrams. And he's worked very closely with Buoy and Osper and Alan to do this report. So my thanks to you, Rob, for a job well done. Thank you.
Thanks.
Roy Robertson.
I just wanted to point out a couple of things about why this is important. First of all, the buoy data in real time is going to be very valuable in an actual spill response around Port Valdez. Both buoys would be able to give you real time information of currents and winds and that type of thing, which would be very useful for spill response. As we be able to build out this record and actually get some trends that will be very valuable for oil spill contingency planning as well. And also any future circulation studies, it'll be more data points for those. So this is just kind of the start of what hopefully is going to be a very valuable set of trends that we can identify.
Thank you for that, Roy. I might add that the pilots bringing ships in and on taking them out are also becoming more dependent on information from that buoy. So they like to know what that current is doing. Austin Love.
Thanks, Robert. Thanks for that report, Rob, and just for clearly describing each of your figures. It was really nice to be able to understand those fully. My question was, in your analysis of the data, did you consider times where like either the wind went over? I think in the contingency plan, there are, wind limits that are supposed to apply in terms of loading at the berth. Did you guys now analyze, with the data we have, when those limits were reached at the VMT buoy stay?
That came up when we were kind of scoping out the parameters of the analysis, and Roy can probably speak to that more. It was decided not to worry about that in the present analysis.
The goal for this was just to identify the trends and the data. Future projects may tie it into other things, but we didn't want to try to start combining things yet. We just wanted to take the data and say this is what the data is. Future projects may try and say, okay, then that applies to something else. But I just wanted these reports to this is what the data has given us.
Thanks, Roy. In Austin, I think that, is there a limit on the weather? My recollection is it wasn't the windage as much as it was the sea overtopping the boom at the terminal. So maybe there's a correlation there somewhere for the future. But Amanda Bauer.
Hey, thanks, Robert. I'm just ready to make a motion for you if you are ready for that.
I am, and so the action that is requested, you have that before you?
I do. You want me just to read that?
Sure.
Right. I move that we accept the report titled Port Valdez Weather Buoy Data Analysis by Robert W. Campbell, PhD, dated August 2nd, 2021, as meeting the terms and conditions of the contract number 6536.21.01 and for distribution to the public.
Thank you, Amanda. Do we have a second?
It's Elijah Jackson here. I'll second that.
Thank you, Elijah. Is there any opposition? Hearing none. We accept that project. Thank you, Rob. Well done.
Thanks.